Hello guys and welcome to Top Channel 101, and today we're going to be making a rain system that you're seeing right now. It has a lot of things. It has the raindrops, it has plashes, and it also has wet maps and this fog effect, and I can control how much rain I want, so I can make it very small. So we have just a few drops and you can see they're random, and I even have that water effect. I can make this intense so that we have a lot of water or a lot of rain, and that's too much, so let's do 0.3, and we have really an intense amount of rain. That is still a lot. Let's do 0.1, and yeah, that's something. Like you can see, we get the droplets, those splashes, everything. It's a complete rain system, even with that fog that you usually see in heavy rain. So this is all done using simulation nodes, and this is the setup. The project files are going to be in the description. The nodes look like a lot, but I promise you they're not. It's a very simple setup. It's just one system duplicated over and over, and you can actually see that these are nearly the same nodes with a few changes. So you can see I have, this would be the water system or the wet map. Then we have these particles. Then we have the raindrops, and then finally we have the fog, all combined to make our rain system. Again, you can examine the project file on my Patreon page or on my Gumroad page. Yeah, so we're going to look at this. You can see even the water displaces the mesh itself, and if you look closely, you only get the wet map where you have the particles. It's not just random, and you can even switch out this plane here, the texture on the plane. I'm just going to use my texture folder as here to switch out this. Let's use a rod here. Switch texture. By the way, if you want to get texture folders, links are going to be in the description. But yeah, see, works. Switch this. Perfect. Okay, so let's see how we can get to this. Start off, we're going to start with the raindrops, and we're going to start with a simulation zone. The first thing we're going to do is we want to generate the rain from this plane. So I'm going to move it up using a set position before the simulation. So set position, I move it up like that. Let me make sure that I apply the scale. Okay, so we want to distribute some particles onto this. Distribute particles, and now we have particles. If we play back, nothing really happens. But if we join these particles back into the zone, remember, this simulation zone runs every frame. So if we're joining these particles back into the simulation, it means that we'll be adding these points again and again for each frame. So that's why you see that the point count here increases on each frame, as you can see there. But with the point count is increasing, but we don't really see anything. That's because the points are being added to the same position as the last ones. So we're going to change the seed, which will change the position using a time node, and just change the seed on each frame using a frame. So you can see now we have the particles. I'm going to reduce the density so that we don't have too much particles. Now we need to have these particles fall, and to do that, I'm just going to use a set position after the join geometry. A set position. So I want to just move them with gravity. So I'm moving them this much on each frame, and that's why we get the movement like that. I want to add some directional wind. So no, I think, yeah, that's too much. So something like that is good enough. Maybe increase our velocity like that. Okay, so now we can create the water droplet that we're going to use. I'm just going to create something simple. We don't want to use complicated geometry or a lot of geometry, because we're going to have a lot of particles, and that is going to slow down things. I'm also adding shade smooth to make things smooth. We have our water droplet. We can apply scale and bring it in. I'm going to call this droplet, drag that in. And we want to do the instancing or changing these particles into instances outside here. Remember, everything in this simulation zone runs every frame, so we don't want to change these into instances on every frame. We want to do that once, so let's do it outside here after the simulation. So we're going to use instance on point. These are going to be our instances. Perfect. Scale this down like that. Then maybe make this a bit tall. If we play back, let's do that. You can see that our particles don't align correctly with the direction they're going in. So to do that, we're just going to use the align Euler to vector, and the vector we're going to use is the velocity of these. If you use the particle position, it will just create something weird. It won't really give you the direction you want. You can see what you get. So instead of using the position, we want to capture the velocity directly, and to do that, we're going to first create a variable here, a variable of this. So create a new vector, and this is going to be the velocity. So to do that, I'm just going to copy these values using a combine xy. So negative 0.05 and negative 0.18 is going to be our velocity. So just doing that is we're basically doing the same thing, except let me first remove this rotation because it's confusing. We're just capturing the same this setup so that we can output the velocity here. And now if we use that as the vector for our align Euler to vector, we get the right direction. We just need to get the correct rotation. Okay, it seems that this is flipped, so I'm just going to rotate it 180 degrees so the rain runs the correct direction. Perfect. Since the density is a bit too high, so let me try 0.1. Make sure I'm saving. We are done with the first part. I'm just going to bring this up a bit. Perfect. Now, the second part, we can start working on the secondary particles or these splashes, those splashes. So to do that, let's just copy the entire system from here, Shift D, because this is also going to be a simulation. So we need the geometry. We don't need these particles, and we can preview them here. We don't need these particles to start from the top there. So I'm going to remove this set position. So they are starting on the ground. Yeah, so what we have is this. And the great thing about this is that if we change the direction of these, because we have this setup of aligning the velocity to the Euler to the velocity, these particles will also change direction. For example, if I, instead of get rid of this and use a random value as our new velocity, because remember, we want the splashes to also have that randomness as well, because they are splashes. You can see, yeah, the direction of these also goes way up. Let me first scale this using a vector math. Scale down the velocity. You can see that they also follow the direction like that. Now we want random splashes. So what we're going to do is add this velocity using a vector math. So add the velocity and some randomness to this, and we should get exactly what we had before. And we want randomness basically in all directions, except we don't want particles to go down like that. So we don't want any negative Z movement. So yeah, we want things to fly. The next thing we want to do is add some gravity. So to add gravity, we just subtract some value. So maybe 1. That's too much, 0.01. That seems like it's not enough. The reason why it's not enough, remember this loop is running every frame. So this setup here is overpowering the gravity. That's why these are flying all the way. So what we can do is bring this down a bit and just scale this up. I found that if you scale this velocity up a bit and you normalize it so that it doesn't overpower the gravity, So normalize everything, normal. Yeah, you can see that we get the gravity working on these. I also want to scale down. I want to scale down the randomness a bit. Yeah, so we have something like that. I'm going to increase the gravity just a bit. And just amplify. And so we have some particles going up like that. Now, we don't want this effect where all of them are going down, and I think we still also have these rain particles going on forever. So what we can do is delete them after they hit the ground, and remember our ground is here at the origin, which is 0, 0. So what we can do is after we make these particles, which are here, the rain particles, we can start by deleting those. We want to delete any particles that go above, below our 0 mark. And for that, we can use the position and separate its component. And look at the Z position. You can see that anything that goes below our 0 mark, it becomes black. And we can use a compare node to select that. So anything less than 0 should be selected like that and deleted as well. So I'm just going to use delete geometry here and just connect that like that. And now you should see that our particles should get deleted immediately when they connect there. We want to do the same thing here. So I'm just going to copy this, and that should also do the same thing for us, deleting these. Perfect. So if we join these together, join geometry, this and this, you see we're going to run into an issue. These particles, the splashes, they're forming before the raindrops hit our ground, and I think the raindrops are falling really slow, so I'm going to speed them up a bit. The splashes are happening before our particles, and they seem to be in the wrong place. So what I'm going to do is scale up the ground so that we cover a wider area like that. But we only want the particles to be emitted where we have these splashes. So what I'm going to do is, let me come here, push this a bit forward, because we want to use these particles to determine where these particles are going to be emitted. And for that, we're going to use a proximity node. And the reason I'm using these points instead of instances, because the proximity node does not support instances. If you try to preview that, you will get an error like that. So just use the points, which because remember we have the points and then we instance on those points. So let's just use those points directly here. And let me get this preview. We want this to be our geometry. Yeah, so we are not seeing anything because we need to first change this to points to see something. You can see we're seeing something, but actually I want to see the distance instead of that. And the reason why we're only seeing white is because we don't really have enough resolution for this. So I'm going to subdivide it quite a few times until we can see, yeah, the points like that, where the points are hitting. Yeah, so something like that, which is great. We use that as our mesh here. Yeah, now we have something like that. We can use this as our selection. Let's first invert that using a compare node, and we can just use, is it less than? Yeah, something like that. So we get that, use that as our selection. And now if we preview everything, we should see that the particles only happen when these collide with the surface, and I will even get the splashes only where these particles are hitting, as you can see there. So the splashes are done, the raindrops are done. Now we can continue on to the wet map. So for that, we can get the entire system, this system here, Ctrl-Shift-D to keep everything connected. So this time I want to join this. Let me add a reroute node here so that we can see what's going on. We don't need this connection. Connect this to this. So here we still have the same thing. We have splashes and we don't want that. And so this can be the same, can use the same transform node, subdivided. We still want the proximity. The only thing we don't want is this distribution. We don't want to turn this into points. We still want the plane, so I'll get rid of that. We can also get rid of the join geometry, and let's just preview this. It's turning into particles because we have the velocity set, and we're turning the points into vertices, basically getting that, which I guess is a nice way to destroying things, but we don't want that. So we don't want to turn this into points or delete any geometry. And so now we definitely don't want this to fall down. We don't want any of this velocity thing. You don't even need a set position. We will need the set position, but later. So yeah, we have that. We can go look at this, and yeah, we see where the particles are hitting. If we look at the proximity node here, look at the distance, we still got that. Now this gives us a starting point, and what we want to do here is just displace this mesh randomly in different areas to create ripples. Let's preview this. We want to create a random selection of vertices that we're going to displace, so I'm going to use a random value, change that to probability. Now if I look at that, you see we have some random value, and I can, let me first get rid of this velocity input. I can use this in here, and take a look at it here. Basically we have the same thing. We can change the selection on each frame. So frame, using the time technique, frame for each seed. So each seed gives us a random value. So if you plug this directly into the value, we're just having an initial value that doesn't changes throughout the loop. So what we can do is add a math node and just add a new selection every frame. And you can see this continuously grows like that, and until we have the entire space filled up like we have in our simulation, where we have the weight map filling up the entire area. But I want the probability, the selection to be very, very small so that we don't have too many points. Okay, so you can see what we have. The only issue we have is that these look too blocky. We want to blur them a bit. So let's use a blur attribute, increase the iterations. Yeah, so if you're having this issue where instead of blurring, they just scale up, make sure that your output here, your view output, you're not looking at a Boolean value. So just make sure that it's actually a float, and that this value is also a float instead of a Boolean. Otherwise, if it's a Boolean, you're going to be seeing blocky effects like that. So make sure that it's a float. Now we can blur them like that, and you can see we already have something that looks good. And if I want, I can even add a ramp, adjust the contrast a bit. You don't want to push it too hard. So it depends on what effect you're trying to go for. So with this mask, we can store this into a named attribute. Can call that rain mask. I'm not sure if I already have a rain mask, so just store that. And now we can use a set position outside here, because if we add it inside the simulation, these values are continuously going to be added to the mesh, displacing it upwards. Let's see if I use a combine XY here on this on the Z. This is just going to be continuously added. The ripples are going to be continuously added to this, and it will just go up like that. So let's do this outside, so that and just bring this here. So you see we have some waves. Let me remove this. We have some stuff going on. Let me do a shade smooth here. Okay, so we have that. Now if we combine this with everything else, yeah, we have that, but again we have the same issue we had with particles. So let's bring back our mask. Our mask here. We don't want it to be that harsh, so I'm just going to blur it a bit. again, make sure that this is previewing this. This is previewed as, yeah, as a float instead of a boolean, like that. What we're going to do is just multiply this with this, so that only where we have the mask, we see these particles. So I'm going to use a math node here. Just multiply this by this. So you can see we already remove, perfect. Only where our drops are is where we see the rain. So I need this to be transferred through the simulation. Perfect. This now can be stored. Yeah, we already have it stored as the rain mask. So now we can go into the materials. I can start, let's go to the materials. I can start with the water droplet. So I can use a set material that create a water droplet here. So it's going to be full transmission, no roughness. Let's apply that to the water like that. We also want it to be on the droplets. And now we can also create ground. And for that, I'm just going to use my texture folders. Let me grab this, import that. Okay, so we have our ground. We can bring in our masks, the rain mask. If we look at that, is it? Yes, this is going to be in the base. This is going to be in the roughness. Our mask, we want to use it to make things very, very reflective. So I'm going to use a mix node here. Use a color for this. This should be our factor, and this should be in our roughness. So I can make this very dark. Let's look at this and see. And use a ramp, make something to make the reflections really clear. I think I'm going to do another mix node here with the same mask, but this time darken the pixels using RGB curves here to make those area a bit darker. Now we have our raindrops. Yeah, something like that. Yeah, making those pixels darker gives it that wet look. I think the displacement should be a bit higher. So let's subdivide this to a level 8 and offset this a bit more. So I'm going to use a math node, multiply, just to make the effect a bit more amplified. And let me increase the blur effect. And you can increase. So right now what is left is just playing around with the effects to get the settings you want. And you have the project files to look at. Maybe the last thing that I didn't explain was this fog effect, which is using the same things. So we start off with the geometry, distribute some points in the simulation. Let me first remove this fog so that we can tell where our simulation is. Yeah, so we have some points that fall like rain. Instead of using droplets, I use a plane. This plane here. You can see it's just a bunch of planes rotated around. And the way you do that is just get a plane, duplicate it in edit mode, rotate it, and I just start rotating this in different directions. And then what I did, I gave this material, this kind of a smoke material. Let me make a duplicate here, just so I don't mess up my material. The way I made this material is I used a gradient, a texture gradient, so that in every direction you look at it, it's going to be like a circle, like that. And I inverted the circle, used some noise some light noise, and this noise is animated a bit. So to add that animation, you see, and subtract that from our gradient, and you get a noise effect like that. And then use a translucent and transparency material, and make sure you have alpha blend on, so you get a settle look. And I can amplify the effect so that you can see what is going on. Yeah, so it's basically some fog effect animation happening like that. And when you instance these particles, give them some slight rotation and movement, and I also delete them as they touch the ground. You get that rain effect, you get that fog effect, and basically using the same setup that we were using here. Yes, that's it. If you want to check out the project files, they're going to be on my Patreon page, Gumroad, and yeah, see you in the next video.